An unexpected discovery made by the James Webb Telescope reveals city lights in space, located 7 trillion miles away from Earth. This remarkable finding has sparked curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri b? Could this indicate the presence of life beyond our planet? Join us as we delve into how the James Webb Telescope detected these extraordinary objects in space. For years now, scientists and humans at large have waited and researched to get a glimpse of life beyond our solar system. Any evidence perceived to back up this space fantasy has been welcomed with open arms. Recently, the scientific community received the shock of their life when solid evidence of life forms existing in space was observed by the James Webb Space Telescope. While scouting outer space and reporting vital information back to Earth, the James Webb Space Telescope noticed strange city lights shining from the exoplanet Proxima Centauri b. These lights were just as their name implied, lights that looked like they lit up a distant city. The possibility of an alien city existing on the star has left scientists reeling in wonder. Every one of them is baffled because it seems like this is the existence they've all been waiting for. If this turns out to be true, as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we're only just discovering it. Peering into the city lights that are located 7 trillion miles from Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima b exoplanet, where the city lights were found, as tricky. He said so because the star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. Not so for this exoplanet, as its infrared nature is quite different from that of its host star, Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, which is able to easily detect infrared wavelengths. The distinct heat signature of Proxima b will play a great role in discovering the universal secrets of its atmosphere, and that'll be done because of the latest technology of infrared imaging capabilities possessed by the JWST. Scientists plan on using the telescope to reveal the mysteries surrounding this planet's atmospheric components. They also aim to use the Webb telescope to assess the possibilities of residing on this exoplanet. The James Webb Telescope has an infrared sensitivity that's poised to explore what happens at Proxima Centauri b's nighttime. Picking up the faintest rays of light in the cosmic darkness is usually a struggle for space telescopes, but not for the JWST, as it can pick out even the tiniest rays of light from space. It's the perfect instrument to verify if the rumors of city lights on Proxima b's night side are true or not. Every artificial illumination in the cosmos can be sensed by the telescope as long as it falls within a frequency band that's 1,000 times narrower than the starlight. Proxima b has an interesting relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the bubbling radiant energy possessed by the star. A spectral edge also reflects incoming light rays at the same time. When Proxima b completes its orbit around its host star, Proxima Centauri, it experiences day and night periods similar to what we have on Earth, with the daytime getting high on solar heat and the evening experiencing coolness. The planet is known to have temperature fluctuations that are determined by its composition. For example, if there's no atmosphere on Proxima b, the difference between its day and night periods will be wide and far between. If there's no moderating influence of atmospheric gases and oceans, the temperature of the day side will be extremely hot, while the night side will drop into cold darkness. The degree of temperature variation is a good subject for astronomers to unravel a deeper understanding of Proxima's atmospheric composition. Having an unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around the Earth falls in alignment with Proxima b's orbital period, making complete observations of its day and night periods within 11.2 Earth days. Since it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good pointers in determining if there's life are the presence of gases like oxygen, water vapor, and methane. If these elements can be found on the planet, it means that it supports habitable conditions. The process of successfully determining this requires scientists to be meticulous enough as they capture and examine light rays that move through the planet's atmosphere. This is a very challenging task to undertake, even if the JWST possesses great capabilities for characterizing planetary atmospheres. It has a different major objective. The telescope has been customized to only analyze the variations in water vapor, carbon dioxide, and methane concentration when it comes to identifying bonded oxygen, which is a vital indicator of life. The JWST is limited in this area, but even at that, the telescope still has valid reasons to search for other elements on the planet, such as ozone, which indicates an accurate level of vitality in the atmosphere. It's also worth noting that the James Webb Space Telescope doesn't have absolute capabilities, and it can only peer at a few of the closest habitable worlds to Earth. Carrying out a thorough atmospheric investigation, astronomers are now tilting toward ground-based observatories like the Extremely Large Telescope, fondly referred to as ELT. The ELT is a telescope that has been scheduled to start operating in 2028, and it's carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It'll produce data on these mysteries, planets that will offer comprehensive and vivid insight into their level of habitability are eagerly anticipated. NASA scientists and everyone else are happily waiting for the deployment of future space telescopes. Until then, however, the James Webb Space Telescope remains a vital tool in our quest to uncover the mysteries of distant exoplanets. Even with its current limitations, the Webb telescope has the potential to offer deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future. Scientists have an objective for future space telescopes: to reduce the amount of bright light coming from a planet's host star, so astronomers can better see the lights reflected from a planet itself. They plan to do this by using internal masks or gigantic external satellites that are shaped like an umbrella, similar to using your hand to block out rays of the sun to enable you to see an object more clearly. Reducing the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from a distant exoplanet, allowing for vivid analysis of its atmosphere and likelihood of supporting life. Doing this comes with its own challenges, however. Scientists will have to differentiate between gases generated from life and those from geological processes such as volcanic activity. Astronomers aren't giving up on understanding the characteristics of exoplanets, so they're more able to spot signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we're yet to find. As we stretch our understanding and exploration of the cosmos farther and farther, we're better positioned to understand the intricate workings of the universe and our various roles in it. After searching through all the planets in space, scientists have yet to find anyone that hosts life. Despite decades of searching through space for signs of life, the quest for forms of life on other planets continues. Are we alone in the universe? For millions of years, throughout human civilizations, humans have always wondered whether they are the only ones in the universe. This age-old longing still hasn't left us in this present time. Even now, scientists have the James Webb Telescope in outer space, trying to spot alien civilizations hidden among us while studying all kinds of planetary bodies for signs of life. At the same time, a popular narrative has spread in recent times that some aliens are truly out there in the stars, just waiting for humans to find them. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called Search for Extraterrestrial Intelligence in 1984, known as the SETI Institute. It is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. The reason for focusing on radio signals is because of their ability to travel long distances without getting scattered or absorbed like other types of radiation. Due to this characteristic, radio signals are more likely to be detected by the 42 radio telescopes that constitute the Stellar Allen Telescope Array found in the Cascade Mountains of California. Though the SETI Institute has religiously observed signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years. Jill Tarter is enthusiastic that they'll have a positive result, as they want to use the tools of the 21st century to accelerate the search. In the words of Jill, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." All of that continued until recent reports from NASA implied that the James Webb Space Telescope spotted city lights from a planet close to Earth. The JWST is the giant trump card played by humans in getting a finite grasp of the universe. It's currently the most advanced instrument in all of mankind's efforts to unearth the mysteries of the universe. The telescope is currently floating about 1 million miles away from Earth, sending accurate details about the earliest periods of the universe. It's designed to capture the previously elusive facts about space as it delivers greater clarity on the formation of galaxies, planets, and stars alike. Astronomers haven't failed to capitalize on the JWST's cutting-edge technologies, such as its stellar camera feature and filters, to spot and analyze the delicate colors that surround celestial objects. Researchers are comfortable using the telescope to collect data about the physical properties and chemical compositions of celestial bodies located far away in the cosmos. This was achieved by isolating specific wavelengths of light. Far beyond just observing, the Webb telescope continuously gazes upon the atmosphere of exoplanets for faint traces of life, no matter how little. It has an unrivaled power to analyze the interplay of time and space, and has exposed some of the most intriguing findings ever. One such finding is the discovery of more mass than what was previously believed to have existed in the universe. This mass has been stashed away in several giant galaxies, effectively casting doubt about the earliest layout and proportions of the universe. Humanity has since set out to explore the farthest reaches of the cosmic plane, using the JWST as an integral tool for achieving this. Through the telescope, new information on isolated worlds will be documented, and more astrophysical information will be available to solve the mysteries of these planets. 20 years ago, the cosmic realm outside our solar system wasn't explored. Since that time, however, astronomers have identified over 4,000 exoplanets that orbit distant stars, showing just how far human ingenuity can go. Still, all of these discoveries are regarded by NASA as just touching the tip of the celestial iceberg. Scientists are of the opinion that, in reality, there are trillions of exoplanets littered all over the cosmos that haven't been discovered yet. Not giving up, over the decades, scientists are still exploring space in hopes of fishing out alien habitats in places where humans haven't ventured. They've had glimmers of hope during this quest from time to time. When Galileo hopped on a spacecraft traveling to Jupiter, its spectroscopic instrument unknowingly revealed a unique spectral signature that lent credence to extraterrestrial vegetation. As the search for life beyond Earth continues, the James Webb Space Telescope stands at the forefront, promising to deepen our understanding of the cosmos and potentially unveil the existence of life beyond our planet. With every observation, scientists edge closer to answering one of humanity's oldest questions. Are we alone in the universe? The quest persists, fueled by curiosity, innovation, and the boundless possibilities that lie in the vastness of space.